Good morning, everyone. The next topic that we are going to see under differentiation is exponential and logarithmic differentiation. First, in order to solve any logarithmic or exponential differentiation, we will first have to know the list of formulae for logarithms. That is, as we have seen in our previous classes, the laws of logarithms as log m into n to base a can be written as log m to base a plus log n to base a. Similarly, log m by n to base a is equal to log m to base a minus log n to base a, meaning the basis remains the same. If it is log of multiplication, it becomes two different functions with a plus sign. If you have division, log of any division, it takes subtraction form with the same base. Now suppose I have log m power n with base a, then the power becomes the base into log m, that is log m power n to base a is equal to n into log m. The base remains the same as a. Next, in order to solve the next exercise, we have two important formulae of differentiation. One is d by dx, or differentiation of log x with respect to x is always equal to 1 by x. Second, differentiation of e power x with respect to x is always e power x itself. One more, d by dx of e power minus x is equal to e power minus x into d by dx of minus x. This becomes e power minus x into d by dx, minus remains minus, d by dx of x is 1. So therefore minus e power minus x. Therefore d by dx of e power minus x is minus e power minus x. Keeping these formulae in mind, let us start solving exercise 5.4. Under this 5.4, we have the first question as differentiate the following with respect to x given e power x divided by sine x. Now, because you have division, it is easy for us to apply quotient rule. We have, let us write y is equal to e to the power x divided by sine x. Let us recall our quotient rule. Quotient rule says d by dx of u by v is equal to denominator v square, numerator v into d u dash, that is d by dx of u minus u into v dash, where our u is equal to d by dx of u and v dash is equal to d by dx of v. So keeping this formula in mind, let us call this as u, this as v. It becomes dy by dx is equal to v square. Our v is sine x, so it becomes sine square x. Then v, our v remains the same, v is sine x into d by dx of e power x minus u remains the same, into d by dx of v, which is sine x. Further solving, sine x, d by dx of e power x is e power x itself minus e power x, d by dx of sine is cos x whole divided by sine x the whole square. I can take out e power x common, it becomes e power x sine x minus cos x whole divided by sine square x is our y dash, or dy by dx. This is the first problem of exercise 5.4. Let us take up the second problem. Second problem says y is equal to e to the power sine inverse x. I repeat the question, y is equal to e to the power sine inverse x. Now let us differentiate on both the sides. D by dx of e power, let us call this as x. E power x means d by dx of e power x is e power x itself. So this will remain the same. Let me first write on the first step, e to the power sine inverse x. Next step, dy by dx is equal to d by dx of e power any function will be the same thing into d by dx of the top function, that is sine inverse x. Now further, e power sine inverse x, we know that differentiation of inverse trigonometric functions, d by dx of sine inverse x is equal to 1 by root of 1 minus x square. So therefore this takes the form 1 divided by root of 1 minus x square. Therefore my final answer is equal to dy by dx is equal to e power sine inverse x divided by root of 1 minus x square is the required solution for y is equal to e power sine x. Let us take the next problem. Y is equal to e to the power x cube. So y dash, I can call dy by dx as directly y dash. Now it is equal to d by dx of e power x cube. This is d by dx of x cube is e power x cube only into d by dx of x cube, which is e power x cube d by dx of x power n. Recall d by dx of x power n is n into x to the power n minus 1. Therefore in place of n it is x cube. This becomes 3 into x to the power 3 minus 1 2. So this becomes 3x square, or I can rewrite this as 3x square e to the power x cube is my required dy by dx. Hope you have understood. Let us go to the next problem. Fourth problem, it says y is equal to sine of tan inverse e to the power x. Carefully look into this. It has three functions now: sine, tan inverse and e power. First I will differentiate and get the differentiation of sine. Differentiation of sine is cos, differentiation of tan inverse, and then differentiation of e power x. So let us recall everything now. So d by dx of sine is cos, then d by dx of tan inverse x. Why tan inverse? Because I have tan inverse in my function, that is 1 by 1 plus x square. Again I have d by dx of e power minus x. We've already seen it is minus e to the power minus x. Keeping these formulae in mind, I will start differentiating this step by step. So dy by dx is equal to, first d by dx of sine is cos, keep the function as it is, into d by dx of tan inverse of e power minus x. This is chain rule. Remember chain rule. So cos of tan inverse of e to the power minus x into d by dx of now tan inverse. Remember tan inverse means 1 by 1 plus whatever is the x value, it's square. So 1 by 1 plus x square, that is e to the power minus x square into d by dx of e power minus x. One more chain rule. So cos of tan inverse of e power minus x into 1 by 1 plus e power minus x square into d by dx of this is minus e power minus x. Rewrite this in a proper format so that my final answer becomes dy by dx equal to, because it's minus so I'll keep this first, minus e power minus x whole divided by, I have cos of tan inverse x into cos of tan inverse of e power minus x whole divided by 1 plus e power minus x square is my final answer. Hope you have understood. No doubts. Any doubt in any steps you can ask in the comment section. Next question, y is equal to log of cos of e power x. Same method, start applying. So y dash is equal to d by dx of log of cos of e power x. Let me come d by dx of log 1 by whatever is the function, keep it as such, into d by dx of cos of e power x. Applying chain rule, 1 by cos of e power x, d by dx of cos is minus sine, recall the formulas, is equal into d by dx of e to the power x. So minus sine by cos, I can rewrite it as tan of e power x into d by dx of e power x, e power x. So my final answer will be dy by dx equal to minus e power x into tan of e power x. This is our required solution. Let us move to the next problem. Next problem says y is equal to e power x square plus and so on e power x power 5. Now before differentiating this, let me expand this. So now y is equal to e power x square, e power x cube, e power x power 4 and e power x power 5. Now separately let us differentiate. Apply differentiation. Dy by dx is equal to d by dx of e power x, d by dx of e power x square, d by dx of e power x cube, d by dx of e power x power 4 and d by dx of x power e power x power 5. Now let us start. So dy by dx is equal to d by dx of e power x is e power x itself. So the first function remains the same. Second, I have d by dx of e power x square, that is e power x square. It becomes e power x square into d by dx of x square. Third function, e power x cube into d by dx of x cube. Fourth function, e power x power 4 d by dx of x power 4. Fifth function, e power x power 5 d by dx of x to the power 5. Next, so e power x remain the same, e power x square remain the same, d by dx of x square is 2x plus e power x cube, d by dx of x cube is 3x square into e power x power 4 remain the same, x power 4, d by dx of x power 4 is 4 into x cube plus fifth function e power x power 5 d by dx of x power 5 is 5x power 4. Rewrite this properly. E power x plus 2x e power x square plus 3x square e power x cube plus 4x x cube e power x power 4 plus 5x power 4 e power x power 5 is my required derivative. Next, let me come to the next problem. The next problem says y is equal to root of, so sixth, the next problem, seventh problem says y is equal to root of e to the power root x. Because there is root, let me make a small change in the question. Let me square on both the sides. It becomes y square is equal to root of e to the power root x whole square. So root and this cancels out. So now I'm left with y square is equal to e to the power root x. It becomes a little bit easier for us to calculate. Next, let me differentiate on both the sides. It becomes d by dx of y square is equal to d by dx of e to the power root x. So d by dx of y square becomes 2y into dy by dx is equal to d by dx of e power is e power itself into d by dx of root x. Recall, d by dx of root x is 1 by 2 root x. Keeping the formula in mind, this becomes 2y dy by dx is equal to e to the power root x into 1 by 2 root x. Now bring 2y to the denominator, so multiplication becomes division. So 1 by 2y into e to the power root x whole divided by 2 into root x. Rewriting this in the proper format, e power root x divided by 2 into 2, 4, y into root x. Replace y from the question. That becomes e to the power root x divided by 4. I'll rewrite first root x and then y is root of e to the power root x is my required final answer. Hope you have understood this exercise. In the next class, we will be looking into logarithmic differentiation. Any doubts in any steps or any of the questions, you can pin me in this video below. Thank you.